In this video, I'm going to go over how to make a game with a basic falling mechanic in Unity. I'll explain how to do it in Bolt as well as in C#. So if you watch the previous video, you'll see that the setup for this is very similar to how we set up the rising mechanic. It's got a lot of similarities in how you can approach the problem, as well as how the logic for the problems can be solved. And in terms of scene setup, I've got some sprites again. In this case, we're going to use these different platforms. I've basically tagged them as good platforms and bad platforms. This again will allow us to easily access their tags and decide what we want to do when we actually collide with them. Then the coin is also set up with just being a trigger where we can collide with it and then pick it up. And then the player is just a sprite with a circle collider 2D and a normal rigid body 2D. One thing to note is you can constrain its Z rotation to prevent it from sort of rotating or flipping over in a direction if you don't want that to happen. But other than that, I think that's the basic setup. Let's get into actually creating the logic. So I'm going to start by creating the bolt logic. So I'm going to go to my scripts and create a new flow machine and call this one our player controller falling. And then I'm going to assign that onto our player, making a flow machine component, and then assigning that to the component. And okay, let's start with this. So if you look at the previous video, the setup for this is very similar in how we control the player as well as how we detect collisions. So to go over that, we essentially want our player to follow our mouse position once we click and hold down our left mouse button. We want to be able to control the player moving left and right, but we want gravity to let the player fall down, and essentially when it hits a good platform we want the player to bounce back up, and when it hits a bad platform we want the level to respawn, or at least to reload. So let's get started. So we want to start by actually getting the X position of our mouse and then setting the player's position to that X position. And because we're going to be working with a rigid body component, we want all the physics stuff to happen in the fixed update. So let's start by creating a fixed update node. And then in this case we want to use a rigid body 2D set position. If you watched the previous video, you saw we used move position, which was better because we were controlling the actual speed and the movement in the Y direction. But for this, because we want gravity to control that, we're just going to use a normal set position and then use our X of that component to actually move it left and right. So let's get into that. So I'm going to add a rigid body 2D dot position there you go, and we want set, and then essentially we want to split up this vector 2 that's in there. So I can just say new vector 2, and we want the X and Y exposed. Okay, so now we want to get our mouse movement into the X and just let gravity control the Y. So let's start with the X. The easiest way to do this is we want to check for when the mouse button is being held down, to then move the player to that position in world space relative to where the mouse is on the screen. We don't want the player to actually snap to that position of the mouse. We do want him to sort of have a little bit of a follow to get a smoother movement. So we're going to use a lerp function. So math.lerp, and essentially what this will allow us to do is have the player smoothly go from point A to point B with a predetermined speed that we can set for the player. So let's connect that to the X. And now for this, to get our start position, which is just wherever the player is right now, we can add a transform.position get, and then we just want that X position. So we can say vector2 dot X. and that is what we want our A to be. And then for the destination, we want it to be a float variable that we can essentially change based on the mouse position. So let's go ahead and create an object variable. We can call it our mouse position X, and add that, and we want that to be a float. Okay, and drag that in, and that'll be our B. And then for how fast we want it to actually move to that position, we want to be able to control that speed as well. So we can create another variable and essentially call that slide speed, because we're basically going to control how fast the player is sliding across the screen. So let's add that, and that is also going to be a float. And I think we can probably set it to something like 0.5. We can test the actual speed, and the nice thing about setting it up as a variable is you've got a lot more control over the actual values when you are creating all the logic. So let's drag that in and set that to the T, and essentially this is going to be all the logic for our left and right position of getting the mouse position. So this is essentially going to move the player left and right, so move player to mouse position. And then for the Y position of the player, we basically just want him to look at wherever it is now and whatever momentum the rigid body has, and just continue with whatever is happening. So essentially listening to gravity and just continuing to wherever it was going to be. So for this, we're going to add again a rigid body 2D dot transform, and then we basically just want to get our transform position, and then we want to get just the Y of that, so vector2.y, and that's what we're going to use for our Y position. So this is essentially just using whatever its current Y position is. Okay, so next, before we continue, we actually want to set what this mouse position variable is, what the value of that is. So in order to get our mouse position, we're going to create a new node tree where we essentially want to check for input, and because we're checking for input, we want to do it in the update, because if we do it in fixed update, then it might skip a frame and it might miss that input. So we'll add an update node, and for this I'm just going to use get mouse button down. This depends on however you want your game to be set up, but for this get mouse button down works fine, or just get mouse button. The difference between get mouse button down and get mouse button up is this will fire every frame that the button is being held. The get mouse button up will fire only the one frame that it releases, and same for down, it'll only fire the one frame that you're actually clicking the button down. So this is the one we want. We want to check every frame, and essentially want to get a branch out of there and say whenever this is true, so whenever we are actually holding down the button, we want to actually we can drag this out, hold down Alt and drag that to set it. We want to set that variable. So in order to get the value that we want to actually set it as, we want to use what's called a screen to world point, and essentially what this is going to do is it's going to take wherever the mouse is on the screen and basically convert that to world units, so the game can see what the actual X value is, so we can use the player position to set that to. So out of this we just want our camera.main, and the position we want to get is of course our mouse position. There we go. And because we only want to use this for the X value, we don't care about the Y value, we're just going to say vector3.x, and then we put that into the set variable, and now every frame that we hold down our mouse button, it'll set that mouse position variable to wherever the mouse is at that frame. So this is essentially set mouse position when mouse is down, or when mouse being held. There we go. So now if we actually test this, the player will fall because it is just using normal gravity, so we can maybe zoom out a bit, but now you'll see if I do actually play, the player should follow, in terms of X movement, it should follow left and right with the mouse. And there we go. You'll see on the left it does follow with the mouse position. Okay, so next we actually want different events to happen depending on which platform the player is colliding with. But I think before I get into that, let's first take a look at the camera, because we do want our camera to follow the player. That way we can actually test things a lot better. For the camera setup, we're basically going to do the exact same thing that we used in the previous video. So if you want to see how we actually made our camera follow logic, you can just watch that piece of the video, because we go over exactly how to set up our camera to just follow wherever our player is. So basically going to be using this one. So essentially we are just checking for where the player's current Y position is, and then just setting the camera to follow the player and keep its X and Z position as it follows the player. If you want more in-depth explanation of that, you can watch the previous video where you do go over that. But for now, this is fine. All we need to do now is actually make sure that we recreate the variables. We do want our player object variable, which is a scene variable. That way we can reference the player throughout the whole scene. It's a game object and it's our player. And then we do want to get our start position, which is just a float. Well, actually, I think that, yeah, that's just a vector 3. So we can add that, and it's just normal vector 3. And then the last one we want to add is our camera offset. If you remember, what this does is it'll allow us to actually add an offset to our camera, so that sort of the player's position is either at the top or the bottom of the screen, depending on our offset. In this case, we obviously want the player to be more to the top of the screen. That way the user can actually see a lot more and have time to react to whatever is happening on the bottom of the screen. So we're going to add that, and that's just going to be a float, and I think -3 should be fine. Okay, I think then we can test that. There we go, and now the camera follows the player as the player falls down. We might just want to make that text a bit smaller. There we go. Okay, so now that we have our camera following our player, we can go back into actually creating the logic for when the player hits a different platform. So again, we want the player to bounce back up once it hits a green platform, and to basically reload the level if it hits a red platform. We also need to set up the coin collection system so that we can actually get score and update the score on the screen. Okay, so setting up the function to restart the level, we're checking for collision with a bad platform. So we want to start with a on collision enter, and again we're using 2D, and then we want to check for compare tag. So we can go game object dot compare tag, and we want to compare the tag of the object we're colliding with, and we want to see whether it's called bad platform. Again, make sure that this tag matches exactly if you are going to use this. There's a ton of ways that you can actually check for what you're colliding with. This is just one of them, but just make sure that that does actually match, because it is case sensitive as well. So now we want to add a branch and basically say if this is true and we are colliding with something with that tag, we just want to reload the scene or the level. So we can go scene manager, and we want actually we want to get the load scene for this one, so we can go scene manager dot load scene, and we just want our scene build index. There we go. And essentially we can now just drag out scene dot build index, and out of this one we can just get active scene. And essentially what this is going to do, it's going to check whatever is our current active scene, and it's going to set that to which scene should reload, and it'll reload the level. Obviously this depends on what you want to do with your game. You can have different functions in here, like losing life or losing score or something, but for this we're just going to stick with this. So yeah, essentially this is going to restart when you collide with a bad platform. And now for setting up, like I explained earlier, I essentially want my character to bounce back up a bit into the air when it does hit a green platform. So in order to do that, we're actually going to use, we can just duplicate the 3 nodes, and we essentially just want to change this tag to compare to good platform. And then this way, if it does collide with something and the tag is good platform, we know it's actually hitting a green platform. And then we just want to add a force in the y direction to get the player to sort of bounce back up. So we're going to go and add rigid body 2D dot add force, and we want the one with mode as well, because we want to set which force mode we want to apply. So first let's create a float variable, and we can call this like jump force or bounce force, and it's going to be a float, and we can maybe set it to 10 for now. And essentially this allows us to give us a variable to change and manipulate basically how much we want the player to bounce, and makes it a lot easier to test while you're actually building the game. So we want that to be the y value of that, so we're basically just going to split this again, so we can go vector 2 or new vector 2, and this is going to be, the x value can stay at 0 because we don't want to add any force in the x direction. We just wanted to add our force in the y direction, so we can just do that. And now by the mode we can say impulse, and what that will do is it's essentially just going to apply a once-off force to this player, where it basically just is a single impulse of however much we made this bounce force, instead of like a constant force over a couple of frames. So yeah, this is essentially going to make the player bounce up when hitting a green platform. Okay, and now let's actually quickly test this and see if it works. The player should now bounce up when it hits a green platform. There we go, it bounces up. And again, now what's nice about this, if I change this value, let's say make it this 2, you can see we can test whatever value we want to put in there, and makes it a lot easier. And now when the player hits a red platform, it reloads the level. Awesome. Okay, and so the next thing we want to do is actually change the score when the player hits picks up a coin. So to do that, we're going to need to add a on trigger into 2D. So let's go and add that. And we're basically going to do another compare tag. And we want to compare what we're colliding with, and the tag should just be coin. Okay, and now we can add a branch after that and say if the player collided with or triggered an object and it is got the tag coin, we can tell it to, in this case again, we can create a custom event on a different flow machine where we can fire off whatever we want to do with the score. So in here I'm just going to say trigger a custom event, and the event name is just going to be add score. And again, just make sure that you spell this correctly, because otherwise it's not going to fire off the right trigger event. Okay, so the event isn't going to be on our game object, so we need to create a new one, new variable at least. We can call this our UI manager, and that's just going to be a game object, and we can drag that in there and say it should check for that on the UI manager. And then lastly, we want the coin to actually disappear when you pick it up. So we can just, there's a bunch of different ways that you can do this, but for our case we just want to say GameObject dot destroy, and essentially the object we want to destroy is the one that we're colliding with, so we can just say collider2d dot GameObject and then assign that, and this should make the coin disappear and fire off our custom event when the player actually hits it. So we want to use this to add our score, or at least trigger it. And then the next thing I want to do is actually create this custom event. So I'm going to go to my canvas in this case, and if you watch the previous video, we did use the same method for this. I'm just going to do a similar method. So I'm going to create another flow machine, call this our falling UI manager. Here we go. And I'm going to go on my canvas, add the flow machine component and assign this. And so the next thing I'm going to do is actually edit this graph and open it up. So in this, all we need is our custom event to actually fire off, so we can add our custom event. Again, make sure this actually matches the same spelling that you used in the other instance. And in this case, we're going to just change a scene variable, which is our score, because we want other objects actually to also be able to access our score depending on how you want your scene set up. So for now, let's actually create a score total, and that's just going to be an int because our score is actually just going to increment in ones. And for this, we actually want to hold down Alt and drag that in to actually set the variable. So what we want to happen is at the start, when this event actually gets fired, we want to set our variable to whatever the score was now plus 1. So now we can normally drag this out and say add, and we want to add 1, so we can just search for int literal and make that 1. And that's basically going to take whatever the score was now and add 1 to it. Then we want the actual UI to update it as well, and for that we need a variable for our text component on our UI. So let's call this our score text, and that's going to be a text component. And what we want to do now is go text.set and then essentially tell it that we want our variable here to be the one that we're changing, and the value we want to add is basically our coin or our score total at the moment. So in order to actually get this to format a little bit better, we want to add some text before the score. So in order to do that, we're going to add a string literal, and we can just add coins with a space, and then out of this you can add basically our current score, but because it's an int, we want to convert it to a string first, so we can just say to string and then drag that into that. Basically this is going to take the word coins with a space and then take our current score and add that to that, and the end result will be coins with whatever our score is. So this is basically our custom event to update score. Okay, awesome. Then we can go ahead and test that and see if that works, but I think before we do that, we need to assign this variable. So let's just make it a text again and drag in our coin count, and just make sure that on our player we did assign this. Okay, so now in our UI manager, just need to remember to assign that as well. Let's go to GameObject and then assign our canvas as our UI manager. And now if I hit play, we pick up a coin and it actually changes our value. And if you check, to double check, you can go to your scene variables and see that our score is actually now 1. And now if I fall down a bit and try and collect another one, the score updates and the UI updates as well. There you go, and I think that should cover that for the Bolt side of things. Yeah, so next I think let's move on to the C# side. Okay, so I'm going to go and go ahead and open up the other scene for the code side. Awesome, so this is the exact same scene, just without any logic in it. So for this we're going to start again by creating the player interaction and movement. So let's create that. I'm going to create a C# script, call a player controller for our falling mechanic, and go ahead and open that up. Okay, so again, the setup is similar to the rising mechanic video, but we'll go over everything. So again, the first thing we want to do is actually create our variables for our mouse position, and so let's create a private float. Can call it mouse position x. And we actually want to use our rigid body as well, so we can just say private rigid body 2D and call that our rigid body 2D. And we want to set up our slide variable that we used to essentially define how quickly we want the player to move left to right to wherever our mouse is. So we can go ahead and create that, so that'll be a private float. Can call that slide speed, and we do want to be able to edit this in the editor, so I can just make that serializable. Okay, and then if you remember, we do want our character to bounce off the platforms as well, and that was a variable as well, so essentially we can duplicate this and create our bounce force variable that we'll need later on. Okay, so first we need to just tell it what our rigid body variable is. So in order to do that, we just say our rigid body 2D variable is get component rigid body 2D. There we go. And that's all we need for that, to actually make sure that this isn't null. Then the next thing we want to do is we can start by getting our input from our mouse that we're going to be using for our movement. So we can add an update and essentially check for whenever our mouse button is being held down. So we can say if input.get mouse button, and we want to use 0. Again, 0 is our left mouse button, 1 is our right mouse button, and 2 is your middle mouse button. There's a bunch of different ways that you can get input in Unity, so it depends on what you want your setup to look like. So inside this, essentially when we are holding down our button, it's going to set our mouse position X to wherever our mouse is and relative to the world space. So what we want to do is say our camera.main.screen to world point. And again, what this is going to do is it's going to take wherever the mouse is on the screen, translate that to an actual vector3 world point, and then from that we can actually use this information to put that into the variable. So in order to tell it what it needs to compare to, we can use our input.mouse position, and we don't want a vector3 because this will generally put out a vector3. We just want the x value of that, so we just say .x. Cool, that's all we're going to do in the update. What we actually want to do now with the rigid body is going to be in our fixed update. So let's add that. So in this we want our x position of the player to essentially be wherever our variable value is for that. So let's go ahead and say rigid body 2D dot transform dot position, and that's going to be a new vector2 because we're working in 2D. And for the x value of this, we want to again lerp between wherever our current position is and wherever our target position is based on our slide speed variable. That way we get a lot smoother input from the character, and the player doesn't actually snap to wherever the mouse is instantly. So I'm gonna go ahead and add a mathf.lerp, and we want it to lerp from wherever the player is now. So our rigid body dot transform dot position dot x to get its x value of where it currently is. We want it to go to our mouse position variable that we create up here, and how fast we want it to do that is by our slide speed variable that we created up top. So again, this allows us to control how fast we want our player to actually move from this point to this point. And then to actually just give it our y position, because for this we're only going to be using gravity, we just want the player to continue falling, so we wanted to keep whatever our current position is on our y. So we can just say rigid body 2d dot transform dot position dot y. There we go. So now if we test this, our player should fall down because of gravity, but then when we do hold our left mouse button, it should follow the x position of wherever our mouse is. Before we do that, we actually need to assign our script onto our player, and then give our actual values for the variables. So I think we used a 0.5 for this, and then our bounce force. For now, we can test it later again, but I think 10 should be fine. And now let's test that. And there we go. The player follows our mouse's x position, but there's a bit of smoothness to how it actually follows that. So that's cool. Okay, so next we need to get our camera to actually follow the player. And again, in the previous video, we created a camera script to make our camera follow our player. And for this, we're going to be using that exact same logic. So if you want to see how we created that script, you can go back to the previous video and see that. But essentially, it's got the exact same logic that we need for this. So we just need to actually assign our player to our player object, and then our camera offset again is probably going to be -3, so that we have this extra space at the bottom of the screen. And if we test that, there we go. The camera offsets and it does follow the player around as it falls. Awesome. So now the next thing we need to do is actually check for when we are colliding with the different stuff, and then based on what we're colliding with, perform different actions. Okay, so the first thing we want to do is check for which platform we're colliding with. So for that, we're going to be using a on collision enter 2D. And we're going to start by comparing what tag we're colliding with. So we can say if other dot game object dot compare tag, and we can start by looking for our good platform. There we go. And then if we are colliding with our good platform, remember we just want to add a force to make the player bounce back up. So we can just say rigid body dot add force, and for this we're going to say new vector 2, and we want our x value to be 0, because we don't want to add any force in our x direction. We just want the player to bounce back in the y position, and for that we're going to use our variable that we created up here, and that's what we're going to be using for that. And just an extra thing is we need to define again that our force that we want is an actual impulse, so we can say force mode dot impulse. For this we actually need to say force mode 2D. By default it will suggest whatever the easiest one is, but do remember, because we're actually using 2D physics and 2D rigid bodies, this also needs to be 2D. Awesome stuff. There we go. Okay, now we can actually, because we're comparing this, we can actually add our bad platform in as well. So there's two ways we can actually check this now. is we can do the exact same thing in compare tag for a bad platform, but because we know how we've set up our scene, there is only one other thing that the player can collide with. If it's not a good platform, then we know it's a bad platform. So we can just say else reload the scene. In order to do that, we do need to add Unity Engine scene management, and while we're here we can probably add Unity Engine.ui because we're probably going to use that later again for the score. And then in order to reload the scene, we can just say scene manager dot load scene, and we want to tell it to reload the scene that we are currently in, so we can say again scene manager dot get active scene and dot build index. This will basically see what scene we're in right now and then just restart the scene. Again, depending on what you want to do with yours, you'll probably have different stuff in here depending on if you want the player to lose health, if you want the player to lose their life, or anything like that. So now if we actually test it, the player should bounce back when it hits a green platform, and the level should restart when he hits a red platform. There we go. Bounces off the green platform and then reloads the scene when it hits a red platform. Awesome stuff. Okay. Then the last thing we want to do is actually get our player to pick up the coins again and update that score up top. So before we get into that, we probably want to create our variables for our score and our text box. So let's create a public int, and we can call that our current score. And then we also want a public text, and we want to name that our score text. If you do not get this text variable suggestion, just make sure that you do have your using Unity UI line here up at the top. That'll allow you to actually be able to access that whole library. Okay, so what we want to do is whenever our player is triggering an object that is a coin, so we can say on trigger enter 2D, we can say if other dot compare tag, and notice we don't need to add other dot game object dot compare tag in this one, because this is a trigger, and that's collision. In the collision there's an extra level where we actually need to see what we're colliding with, and with the trigger it automatically knows that it's the game object that we're colliding, or that we're triggering at least. So in this we can say we're looking for our coin, and just make sure that this matches the exact same spelling as your tag. And then we can say if it collides with the coin, we just want to add to our current score, and to do that we can just say plus plus. Again, this does the exact same thing as when you say your current score is whatever it was plus 1. That's basically doing the exact same thing. It'll increment it by 1, and once you actually pick up the coin, we do want to destroy that coin. So we can say destroy, and we want to destroy other dot game object. Cool. And the last thing we want to do when we are colliding with the coin or triggering the coin, we want to update our score text to actually display our current score. So let's say our score text, which is a text component, so we say score text dot text equals, again with our formatting, we want our score there with a space, plus whatever our current score is. But remember, our score is an int variable, so we need to convert it to string. In some cases it does do it automatically, but just to be safe, we can say current score dot to string, and that way it'll convert it to a string and add it to our score. Awesome. So now if we test that, before we can actually drag that in, we just need to make sure that we have our text field or text component, or the object with the text component actually assigned to our code, and then we can watch if our current score updates and whether the UI updates. So let's test this. Awesome stuff. You can see the current score added 1, the score on the UI updated as well. And then if I try and catch a second one, there we go, the score updates as well. Cool. So that about covers everything that you need to know for creating a basic falling mechanic using either Bolt or C#.